So let us discuss the synopsis of the accept system call. Here you can see that this is the synopsis of accept system call. The accept system call accepts three arguments. The first argument is the integer value, which is master socket TCP file descriptor. Now, what is master socket TCP file descriptor? That we will discuss in the next slide shortly. For now, just assume that when the TCP server is started, the first thing the server has to do is to create a master socket TCP file descriptor. That file descriptor has to be passed as the first argument to the accept system call. So we will elaborate more on this later. For now, just understand the synopsis of the accept system call. The second argument to the accept system call is actually the pointer to the structure of type struct sock addr star. Now this is the standard structure type that is provided by C APIs, and this structure that you pass here is actually an empty structure. That is, you don't have any data in it. So when the client sends a connection request to the server, the client will have some IP address, as well as the client will have the port number on which the client C is listening. This information of the client gets stored in this client address structure on the server side. So on the server, the client information, that is the IP address and the port number, gets stored in this structure when the client connection request arrives on the server. So in this way, server is able to store the identity of the client so that server later can reply to the client. The third argument to the accept system call is the address len, which is nothing but the size of this structure, that is the size of struct sock addr structure, and therefore the third argument is actually a constant. So master socket file descriptor is the file descriptor of the socket which server has opened to listen to new client connection request using socket system call. So we will elaborate more on this. This master socket file descriptor is created using socket system call, and master socket file descriptor is used by the server to detect new client connection request. So it is used to detect new client connection request using accept system call. Remember, the first argument of the accept system call is the master socket file descriptor. So we will have a code walkthrough, and there you will get a better understanding that why do we create master socket file descriptor and what are the various operations or functions that is performed by master socket file descriptor. Then, as I said, that the second argument to the accept system call is the pointer to the structure, and this structure is used to store the client information, that is the client IP address and the port number on which the client is listening. This information is used by the server when the server chooses to reply back to the client. Because server has to reply back to the client, the server would need the IP address of the client as well as the port number on which the application running on the client machine is listening. And address len is a constant, which is the size of the predefined structure struct sock addr. Hence, it is a constant. There are some more APIs like send to, receive from, but their explicit discussion is not worth. As the name suggests, send to eventually sends the data out of the machine, and receive from is used to receive the data received on the machine. So when we will have a code walkthrough, we will discuss these type of system calls right there. So we will have a code walkthrough, and there you will have a better understanding about how different things put together and work together. So next thing that we are going to discuss is the select system call. So select system call allows the server machine to monitor multiple client connections and check which client has sent the data to process. So first of all, select system call is used on the server machine and not on the client machine. Like accept system call, so select system call is also used on the server machine. Now, consider a scenario where you have client C1, client C2, client C3 connected to the same server. Now, at any point of time, any of the client can send a data to the server. and at any point of time some client C4 can send a new connection request to the server. So server has to be in a position, or the server has to be in a state at any given point of time to detect new connection from the new client as well as to detect the new request from already existing connected client, that is client C1, C2 and C3. The select system call serves this purpose. Select system call is used to monitor multiple clients, connected connections, that is client C1, client C2 and client C3, which are already connected to the server. The select system calls helps to monitor the multiple client connections, and it also helps to monitor that which client has sent the data to process. In addition, select system calls also have to monitor the new connection request from brand new clients. So select system call is actually a kind of system call that helps to monitor the server, the state of different clients that are connected to the server at the same time. Once again, suppose you have a client C1, C2 and C3 which are connected to the server S. Now at any point of time, any client can send a data. Suppose a client C2 can send the data, so server should be in a position, or it should be in a state to detect that the client C2 has sent the data and client C2 needs a service. So select system call helps to achieve this purpose. Select system call is a blocking system call. Why it is a blocking system call? See, accept system call is also a blocking system call, and select system call is also a blocking system call. Now what is a blocking system call? Meaning when it is executed, that is when the select or accept system call is executed, the code execution halts. You must have used in your previous programming experience, you must have used scanf or getch. So when these functions are called, you would have experienced that your code halts, or the execution of the code stops and it waits from the user to give some input. In this case also, so these calls are called blocking system calls. That is, they block the execution flow of the program. Similarly, select and accept system call both are blocking system calls. That is, whenever these system calls are executed, the code flow or the execution flow of the program halts, and it stays halt until a specific conditions are met. What are those conditions? Select system call unblocks when either of the two things happen on the server side. So what are those two things? Either new connection request arrives from brand new client, that is client C4, which is a new client. So when the new connection request arrives from the new client to the server, the select system call unblocks. Second condition is when the data request arrives from existing connected client, that is the client C1, client C2 and client C3, which have already established the TCP connection with the server. So the second condition, when the existing connected clients sends the data request to the server, the second condition is met. So when any of these two conditions is met, the select system call unblocks. When we will have a code walkthrough, you will see these points in action. So when select system call unblocks, server needs to check whether it's a new connection request or new data request on existing connection. Right? As I said that the select system call unblocks when the condition 1 or the condition 2 is satisfied. So when the select system call unblocks, the server has to check that the select system call has unblocked because of reason 1 or because of reason 2. So server has to check whether it's a new connection request or new data request on existing connection. When we will have a code walkthrough, I will tell you how to do this. So in the later case, server needs to find which client has sent the data, right? So when the condition 2 has met, the server also needs to check that whether it's a client C1 or client C2 or client C3 has sent the data. When server starts, that is when the server program just boots up, the first thing it does is to create a master socket. That is, in the accept system call, the first argument that we passed to the accept system call was master socket file descriptor. So we are talking here that particular master socket file descriptor. And as I said that when the server starts, the first thing the server does is to create a master socket file descriptor. And that file descriptor is used only for one purpose, that is, it is used to detect arrival of new connection requests from new client. So master socket file descriptor is not used for detection of data requests from existing clients, but it is used for detection of new connection requests from new clients. The master socket, once created, gives birth to rest of the communication file descriptor for clients. So we will discuss this scenario, that how this scenario is. So we will going to discuss the scenario, that what does it mean when the master socket, what does it mean that master socket file descriptor gives birth to rest of the communication file descriptors for clients. So what are communication file descriptors? C provides a data structure called FT_set. So this is the standard data structure that is provided by the C APIs, which is actually a collection of file descriptors. Now what is file descriptors? That also we will discuss in detail, that what is actually file descriptors. As I said earlier, file descriptor represents a client connection. So this is how we create a read FDS set, that is FD_set, it is a data type, and read FDS set is a variable name. So what is this read FDS? It is actually a collection of file descriptors. So it is a collection, or you can say it is a set. And what is a file descriptor? File descriptor is nothing but it is just an integer value, and it identifies a client connection. That is, when the server S is connected to the client C1, it will have a file descriptor, say 6. So 6 value will identify the connection of the server with the client C1. Similarly, when the server S is connected to the client C2, it may have a descriptor 7. So 7 means the connection between the server S and the client C2. So this is the operating system that assigns this value 6 and 7, or any positive value. So it is up to the operating system that whatever value it can assign to the client or server connection. So we term these integer value which actually identifies the connection between the server and the client as file descriptors. And it is these file descriptors that we put these file descriptors in a read FDS set. So we will elaborate more on this, that how different things are put together in the next slide. So in this diagram, we will see the accept system call and select system call together in operation. So for example, let us say you have a TCP server, right? And it has maintained the read FDS, which is actually a set. So it is a set. And currently this read FDS has only one set, which is master socket file descriptor. So let us assume that your server has boots up. Let us assume that your server has booted up and it has created a master socket file descriptor already. Whatever file descriptor it creates, it has to add that master socket file descriptor to the read FDS set. So read FDS is actually a collection of master socket file descriptors. Sorry, it's a collection of file descriptors. So the first thing the server has to do is to add the master socket file descriptor to the read FDS set. And as I said, the first thing the server does is to create a master socket file descriptor and add it to the read FDS set. Now you can see here that the server has called the select system call. The select system call is called on the read FDS set. So whatever file descriptor are present in the read FDS set, the select system call is actually monitoring all those file descriptors. That is, the select system call is monitoring all those client connections with the server. And as I said, that select system call is a blocking system call. When this is executed, the select system call will block here. That is, the execution of the program flow will block here until the conditions of select system call, until the appropriate conditions which unblocks the select system call are met. So going forward, let us say we have a client C1 and it connects to the TCP server. So client C1, the first step, the client C1 sends a connection request to the TCP server, and at that point of time the TCP server is actually waiting on the select system call. And in the read-FDS set, there is only one master socket, there is only one file descriptor which is being monitored, and that file descriptor is master socket file descriptor. So as soon as the client C1 sends the connection request to the TCP server, the select system call gets unblocked. Why it gets unblocked? Because the select system call was monitoring read-FDS set, and read-FDS set had only one file descriptor, which is master socket file descriptor, and master socket file descriptor is used to detect new connections from new clients. So in this scenario, the TCP server has detected that a new connection has received, that a new connection request has received from client C1. So select system call unblocks. So the second step that is taken by the server is to call the accept system call. Accept system call means the server has accepted the connection, and the return value of the accept system call is again an integer value which is called communication file descriptor. So in this case, this is the communication file descriptor. It can have a value, any integer value like 6, 7, 8 or anything. It is this communication file descriptor that the server will use for data exchange with the client C1 for the rest of the lifetime of the connection between the client C1 and the server S. So you can see that the data exchange between the client and the server is happening using the communication file descriptor, which is the return value of the accept system call. Master socket was used only to detect new connection. Now once the communication file descriptor is created, the communication file descriptor is also added to the read-FDS set. So in the read-FDS set, now there are two file descriptors, the master socket file descriptor and the communication file descriptor. The purpose of the communication file descriptor is the data exchange between the server and the existing client, whereas the purpose of the master socket file descriptor is to detect new client connection requests from new clients. Now at this point of time, the server is again blocked on the select system call, and the read-FDS set now has two file descriptors, that is master socket file descriptor and communication file descriptor of client C1. It means that at this point of time, the server is monitoring the new connections. That is, the server is monitoring the arrival of new connections from new clients, as well as the server is monitoring for the arrival of new data requests from the existing client C1. So at this point of time, server is doing both the things, because in the read-FDS set there are two file descriptors. So the select system call is monitoring both the file descriptors. Now let us say from the new client C2, again a connection request arrived to the server. Select system call was blocked, right? As soon as the new connection request arrives, again the select system call gets unblocked. And because it gets unblocked, and the reason for unblocking is that the new connection request has arrived from the new client. Therefore, in this case, the accept system call will be called. And the return value of the accept system call will be another communication file descriptor. This communication file descriptor will be used for data exchange with the client C2. And this communication file descriptor will be added to the read-FDS set. So read-FDS set will now have three communication file descriptors. So at this point of time, the TCP server is now monitoring two clients at the same time, as well as it is also capable of accepting the new connections from new clients at the same time. So you can see that the select system call actually achieves multiplexing. Multiplexing means doing different tasks at the same time. At this point of time, because ReadWS has three file descriptors, the server is actually monitoring three file descriptors at the same time. So more clients will come, more communication file descriptors will be created, and these communication file descriptors will keep on adding in the ReadWS set. So we can say that the select system call is actually monitoring various client connections at the same time. So when we will have a code walkthrough, you will see the entire cycle that is discussed in this diagram in terms of programming. So what we discussed in the previous slide, I have captured that in the form of a flowchart here. So the first thing that the server does is to create a master socket file descriptor and put it in the ReadWS set, right? And then select system call is called on the ReadWS set, and the select system call is a blocking system call, so it is blocked, right? Now, when the new client connection request arrives, only the master socket file descriptor is activated, because the purpose of the master socket file descriptor is to detect new client connection request. So when the new client connection request arrives to the server, the master socket will get activated. So let us assume that the new client connection request has arrived, so this condition will be true. When this condition will be true, the server calls the accept system call, that is, it establishes the connection with the client. And the return value of the accept system call is the communication file descriptor. Using this return value, the server will going to talk with the newly connected client for the rest of the lifetime of the connection. So this communication file descriptor is added to the ReadWS set. At this point of time, the ReadWS set will have a master socket file descriptor as well as the communication file descriptor. And again, the server goes back and call the select system call, and it again gets blocked. That is, it again now waiting for the event from client, either from the connected client or from the new clients. If master socket file descriptor is not activated, it means that the server has received a data on one of the communication file descriptors. Now, server has to find out that which of the connected client has sent the data to me. And once it identifies that client, server services that particular client, that is, the server replies back to that client. Remember the second argument in the accept system call, where we used to save the client information? That client information is used by the server again to reply back to the client. Now, server can choose, depending on certain conditions, whether to close the connection with the client and remove the client communication file descriptor from the ReadWS. It will do so when the server no more wants to communicate with the client. So the connection termination can either be initiated from the server side, or the client can send a special message to the server. Having read that special message, the server can choose to remove the client from the ReadWS set and close the connection forever with that client. So so that particular thing is done at this stage in the flowchart, and after servicing the client, the server again goes back and block on the select system call. So you can see that in this complete cycle, the server, whatever the servers do, it comes back to the block system call. Sorry, the server comes back to the select system call and gets blocked here. So actually you can see that the server is in the while one loop. So it is a property of the server that the server always has to be up and running, and therefore server runs in the while one loop. Right? So now we will discuss all these mechanisms, all these flowcharts, and all these server cycles with the help of our actual code walk. Then things will be more clear to you. So how to implement a TCP server? You have to follow these 10 steps to implement any TCP server. These are the generic steps, and these steps have to be followed in order to implement a TCP server. So let us have a code walkthrough and let us go through all these steps.